Okay, now for the second practice exercise from the second section of practice exercises in Chapter 7, Section G. All right, that's number 2. So the premise says, I have two premises here. If not R, then not S. And I'm also told not R. And then the conclusion is not S. Okay, well now here we seem to have one that makes a lot of sense. If not R is true, then not S will be true. Not R is true, therefore not S is true as well. That looks like a valid argument. In fact, we'll later come in the next chapter to call this modus ponens. It'll be one of our rules of inference that we'll use when we're doing proofs in propositional logic. But for right now, let's just prove that this kind of reasoning makes sense. Let's use a truth table. I have two simple statements, R and S. I need 4 rows. First premise is not R, then not S. Second premise, not R. And the conclusion, not S. Okay. Go ahead and write down my truth values here for R and S. True, true, false, false, true, false, true, false. Same thing over here. True, true, false, false, true, true, false, false, true, false, true, false, and true, false, true, false. And once again, you don't have to do any of that. That's already done for you in the exercises, but I had to do the work. So, all right, now let's go to the first premise. I have a tilde, I have a horseshoe, and I have a tilde. All right, you always go with the tildes first, and then I'll just go from left to right. It doesn't really matter which tilde you do first here, but I'll go from left to right. All right, so this should be the opposite of what I see for R, so I should have false, false, true, true. This should be the opposite of S, so I should have false, true, false, true. Now I just need to do the horseshoe. This is comparing the tilde I see in the antecedent with the tilde I see in the consequent. And remember the rule, if the antecedent is false, as it is here, then the horseshoe is true, so also true here. In both these cases, my antecedent is true, so I need to look and see if my consequent is also true. If it is, then the horseshoe is true. Here, the antecedent is true, the consequent is false, so this is false. Here I have true and true, so this is true. Right, so there's only one line where that came out false. Now for the not R, should just be the opposite of what I see for R, so false, false, true, true. That's my main operator there. Simple enough. And then for the not S, just the opposite of S, so false, true, false, true. That's my main operator there. Now I'm just going to check and see, are there any rows where the premises are both true and the conclusion is false? True for the first premise, false for the second, so that one doesn't help. True for the first, false for the second again, doesn't help. False for the first, doesn't help. Here I have a true premise, and the conclusion is true. So there's no row where the premises are true and the conclusion is false. So this argument is valid, as I suspected all along. All right, so there's the truth table. Hope that helps.